Hi guys, in this video I cover if-else conditions. I start out by explaining the syntax of how to write if-else conditions in Java, and then I go over 3 examples. The first example simply checks if an integer is positive or negative. The next example covers strings and some special consideration that we have to be aware of when using strings in conditions. The final example will simply cover Boolean variables. Let's start out with the basic syntax. The syntax starts out with the if keyword followed by a condition in parentheses. After the condition, I have a then block or a code block. This is also called then block. Now, if this condition is true, all these statements in the then block are executed. Now, with an if-else condition, I simply add the else keyword with the second code block. This code block is also referred to as the else code block. Now, what will happen is that the computer will check if the condition is true. If so, the statements in the then block are executed, and after that, the statements at the end of after the end of the else block continue to be executed. If the condition is false, however, the statements in the else block are executed. And then execution continues after the else block. So whatever the result of the condition is, only either one of these code blocks will be executed, never both. But one of them is guaranteed to be executed. And which one is determined by the result of the condition. If the condition is true, the statements in then block are executed. If the condition is false, the statements in the else block are executed. We can also read this: if this is true, then we do these statements, otherwise we do those statements. Now, you sometimes also see the if-else block without the if-else condition without the blocks explicitly declared. You could use this when you have a single statement in either one of them. Now, if this is true, the first statement here gets executed. Otherwise, this statement gets executed. This is really not recommended. The recommended way is always to explicitly declare the code blocks. Now let's start out with the first example. I declare a variable of type scanner and I initialize it to a new object that listens to system.in. I have to import scanner, and next I prompt the user to enter a value. I declare a variable of type int named val and use a scanner to read the next integer from the console. Now I use a condition, and in the condition I want to check if value is positive or negative. So first I compare if val is larger or equal to 0. If it is in fact larger or equal to 0, this condition will be true, and any statements I write here in the code block will be executed. In this case, I have a single statement that outputs val is positive. Now I also want to output when val is negative, and for that I use an else condition. I output system.out.println, and I output val is negative. Now let's run this program, and I enter 5. We can see 5 is positive. Now I enter something negative, -2, and it outputs -2 is negative. So what this else block simply means is that val is always less than 0, I don't need to check this because I know it already. I did the check up here, and if it's not above or equal to 0, the only value that can be stored in the variable val is below 0. Next, let's move on to an example with strings. Now I read here an integer, and whenever we read an integer, the line break here, the enter key, is still left in the input buffer. So to ignore that, I use scanner.next line to ignore the enter key. And then I start out with the example with strings. So here I output a prompt for yes or no. And I don't add a line break. Next, I declare a variable typed string named answer, and I use a scanner to read in the next line. Now I want to check if the answer is yes or no. And I do a lazy check. I only check if it's lowercase yes, all letters in lowercase yes. If that is the case, I output a line, you answered yes. Otherwise, in this case, let's output two statements. You did not answer yes. And here we can have as many statements as we want. I treat that as a no. So let's run our program and see how this works. First, I enter 0 for the integers. Now I'm prompted to answer yes or no. I answer yes. And here I get, you did not answer yes. I treat it as a no. Let's see why that is the case. Let's run it again. I answer yes. And here we see the debugger. Let's see what we actually have stored here. We have stored lowercase yes. Now when I use the debugger and step over this, and let's stop this. So when I step over this, we see that yes is not actually equal yes. This is a special consideration we have to deal with when we are dealing with strings. So one more example here. I answer yes, and it says you did not answer yes. So it didn't really match it. Now the problem is the strings are not primitive values. Strings are actually objects. And we can have two strings that have the same characters, but they are different objects. You can think of an object that is stored in some memory location. So when we might have a, let's add this up here. We might have a yes here at memory location 010, and we have another yes at a memory location 001. Both of these are yes, but when we are dealing with objects, the comparison that it actually does is it compares the address. It doesn't compare the actual value. Now with primitives such as integers, it will always compare the value. It doesn't care about the address. But by default, when we have objects such as strings, the default is that it compares the memory address. Now, if we don't want this, we should not be using the double equal sign. Double equal sign for objects means reference comparison, and that is dealing with the address. Now here what we want to do instead is dot equals, and in parentheses we pass in the other value. So we do the first variable that we have, or we could do it on a string. Answer dot equals, and in parentheses, the value that we want to compare to. And that means if it is equal, then it will evaluate to true and execute the statements in the then block. So let's enter yes. Now we can see it works. You answered yes. Now there's one nice thing here, which you may have seen. We can also do equals ignore case. So when we do equal ignore case, and I run this again, it will ignore the casing. So I can write all uppercase yes, and it will still treat it as a yes. So there's some more power behind this than simply doing the equal signs, besides that the equal signs doesn't always work. Now the equal signs would work if we treat the exact same string that we had before, because it's at the exact same location. But whenever you do with strings, use the equal method. Now you saw that I called this one on the variable. It is also possible to switch this around. So let me leave this here as a comment. So I could also do yes and quotes dot equals to, and let's say equals ignore case, and then pass my variable in the parentheses. Both of them work. Both of them are strings. This is a string literal, and this is a string variable. But both of them are string objects. So whenever we do comparison for equality on two strings, use the equal methods. Don't use the equal sign. That can sometimes trip you up, especially when you're new to programming. The last example I want to get into is Boolean variables. So when we have a Boolean value, let's say we check the weather is hot, and we say yes, and we want to output, is the weather hot or is it not hot? And what we can actually also do is here, I do that in a moment, we can, instead of initializing it to a true false literal, we can use a condition and evaluate the condition. Now let's start out with is hot. We don't want to do something like this. I mentioned that in my basic condition video. Instead, we just use is hot. And now with the if-else condition, we add else here. What this means is that it's not hot. I add the not operator, the logical not operator. This essentially flips the value here. So this is what the else means. Now, if it's hot, I output the weather is hot. And if it's not hot, I treat that as the weather is cold. Now executing this, and I ignore the first one with 0, the next one with no, and here the weather is hot. So this was true. Now what we can do also is, with the if-else condition, we can have a Boolean and say has answered yes, and now I use the condition here. I do answer dot equal, and let's say I just use equals yes. Now what I'm doing here is I run the condition, the comparison. Is the value in the variable answer yes? Does it equal to yes? If so, this one will be true. Otherwise, this one will be false. Now, if I have very large conditions and I need to check something multiple times, I could simply store the result. And then I can use that multiple times in my condition. Has answered yes. And let's say I need to check that in my program later. Here's some statements. And then here, instead of writing it again, I simply can refer to my variable, which I have checked before. And each of them can have else blocks or not have else blocks. This is something when you deal with Boolean variables, and a lot of times when you're new to programming, you don't really know when to use them. This is another example how you can use Boolean variables to store a result of a condition. I hope you enjoyed this video. Thank you for watching.